good evening. I am Major NMA-Bajuyo, and I am here to represent my final PIT for the subject Numerical Methods. So, first of all, my topic for the said PIT is Newton-Raphson, uh, subsection of the root finding methods. So, to start, I'll just present some sample problems that I tested beforehand. So, you can also see it in the README file if you're interested in the results. So, start. Let me check for a bit. So, as you can see, this is the UI that I had made with windsurf and Streamlit. So, first of all, this is my chosen UI where I can pick, where you can pick also between two themes, which are light and dark. I set it as such so that you can choose whichever is more comfortable for the eyes. So, but I prefer using dark, so we'll just go with that. So first of all is to input the chosen functions. Second is the initial guesses, and then the max iteration. So lastly is the tolerance, which plays a significant role in getting your iterations. So this basically the four here, right here, as you can see, is the most important ones for you to get the table and the chart later on. So I already inputted a value here, as you can see, the sign of x minus 0.5. So the initial guess is 3.00. You can set it, can lower it as you can, or you want to, or something like that. So max iterations is, yes, as well you can set it. You can set it to 15, 14, or something. You can also just type it if you want to. So as you can see. So the tolerance. So basically tolerance is you can input just E in here. You can see. You can't input any letters, so or otherwise you'll get an error for it. So next on is x-axis range, which is basically just zoom in or and zoom out of the table later on that I will show it to you. Well, yeah, I can show it to you right now. So yeah. So basically, this one is you can just set it whenever, whatever. You can set it here, right there. Also set it if you want to. Just set it. Not much. It's gonna go like huge change. I just want to be a bit interactive, so I just did it like that. So next up is the iteration table. So the iteration table is basically where you can see the whole iterations of the following of the parameters that you had set in beforehand. So 0 to 5, 0 to 4 rather. So basically it has a max of 5 iterations for this function, for this example rather. So as you can see, there are basically 7 columns, two of which are basically the iterations that are set right now. So 0 to 4. So basically it's just 5. And next up is this one. You can also just do this like this. So it has a priority number, which is if you can set it like that and there. So basically, yeah, as you can see, the inputs here, the initial guess is 3. So there is 3 right here. And as it goes to compute it from the code, it goes on and on and on in here, right there, in the x sub n, f of x sub n, and the others. It also has a margin of error, so you can basically see it right here as well. I also forgot to mention that you can also do this so that if you can't really see it clearly, you can just do it like this. And you can also download it as a CSV file and even search for it, basically. So yeah. So the estimated root is from from all of these iteration tables. So the estimated root is 2.617994, which basically rounds off to like 2.618. So yeah, after 5 iterations, that is. Yeah. So next up is interactive function uh, and the convergence chart. So basically, this is the graph that I had set up for my UI or my app rather. So you can, as you can see, you can also zoom in normally. You can also pan in right here. It's basically very interactive. I made it like the Desmos calculator. So yeah, you can also download the plot as a PNG. So you can basically just save it for later use or something. You can zoom out. You can zoom in. So you can just see the setup, the whole setup. Yeah. So you can also auto scale like so, so that it can basically just show that the the whole graph right here. So you can also show a full screen like that. So next up is the code itself. So I don't think I have to show as much for the code, since you can also see it in the file that I will be sending in the G class. So basically, I imported a lot of things. This one right here, the Streamlets, Simpy, NumPy, Matplotlib, and bunch of others. So these are basically the code for a lot of things that I had used in the creation of the app. So we'll be moving on to the user inputs, which as you can see right here is the user inputs that I had set, you know, in there. So basically, this is the value where uh you can just if you open the app in the from the start from your preferred like VS Code or Windsurf or like something, but I prefer using Windsurf. So basically, yeah, that's that. So tolerance input, as you can see, Newton-Raphson iterations, yeah. So the tolerance input, as you can see right here, is the has value error, which if you basically if you input the wrong like letters or ABCD or something like that, it will appear as such right here. The center and number like yeah, there. So yeah, Newton-Raphson iteration. So that as you can see from the UI, the app, there it is. Prepare data frame for iteration table and display iteration table as you can see. So I guess the most important thing is the usage of Plotly to show the graph that I had set up in here in the UI right there. Oh, it is there. So yeah, that's basically covers much all of it. And I will be sending also this README file for you to know what is the Newton-Raphson method and basically on how to run the app, to import the parameters and how important it is. So, and the sample inputs and expected outputs, just in case if you don't know how to or what to put into the parameters. So, And also slight notes like if the plotly is missing, the falls back to the static matplotlib plot and displays a warning. So napod siya option na mobalik siya sa matplotlib para in case na wala kay na-download na plotly or if ever na you don't want to download the plotly, you can just use the static one. So yeah, that basically covers all of my code. And thank you for listening. Goodbye.